Hello everyone, this is Aditi Das of 4th Sem CSE in here to give you a detailed explanation on our chosen topic, rules of inference, applications on rules of inference and quantifiers. So this will be a brief introduction by me and my team members Gunarshi, Antarya, Chaitra and Guru Priyanka. I'll be starting with the introduction part, namely the argument. So the argument is defined as a sequence or a list of statements called premises or assumptions, and it returns a conclusion. So an argument is only valid when the conclusion, which is the final statement of the opinions, follows the truth of discussions preceding assertions. Consequently, it is our goal to determine the conclusion's truth values based on the rules of inference. So the rules of inference are also known as inference rules, and they are a logical form or guide that consists of premises or hypothesis, and it draws a conclusion. In other words, an argument is only a valid conclusion is logically following the truth values of all the premises. And there are ways to form the logical arguments, and some of the inference rules are namely modus pons, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction and resolution. The in detail explanation of the rules of inference or the inference rules will be given by my team members, and then moving on to quantifiers. Quantifiers by definition are words that are referring to quantities or refer to quantities such as sum or all, and tell for how many elements a given predicate is true. And we have two types of quantifiers, that is namely the universal quantifier, which is denoted by this symbol, and existential quantifiers, which is denoted by this symbol. Universal quantifier, it denotes for all, where the symbol denotes for all and is called the universal quantifier, where q of x, let us take an example where q of x is a predicate and d is the domain of x, and the universal statement is a statement of the form where all values of x belongs to d is the domain of x, of q of x, where q of x is the predicate. It is defined to be true if and only if q of x is true for every x in D, and it is defined to be false if and only if q of x is false for at least one x in D. A value for x for which q of x is false, that is the predicate q of x is false, is called a counterexample to the universal statement. Then moving on to the next, that is the existential quantifier. This symbol denotes the existential quantifier, which means there exists or for some. So as taken in the previous example, q of x is a predicate, d is the domain of x. Existential statement is a statement of the form where some value of x belongs to d, that is the domain of x, such that q of x is defined to be true if and only if q of x is true for at least one x in D. It is false if and only if q of x is false for all x in D. And then moving on to the next, universal conditional statement. So universal conditional statement is a statement that is both universal and conditional. It's a statement that says that for all members of a certain set, if one thing is true, then the other thing must also be true. So the general form of a universal conditional statement is for all values of x, if p of x, then q of x, where for all values of x, it's a universal quantifier, and p of x, if p of x, then q of x, where p of x is a predicate, applies to the variable x. Q of x is another predicate that applies to the variable x. With this, my introduction part is over. Then I'll be handing over the explanation to my next team member.
Hi everyone, my name is Gunarshi. I am here to explain about the rules of inference and applications of rules of inference. There are 8 types of rules of inference. First is modus pons, second is modus tollens, third is hypothetical syllogism, fourth is disjunctive syllogism, fifth is addition, sixth is simplification, seventh is conjunction, and eighth is resolution. These 8 rules of inference are used to solve the applications of quantifiers, and we can solve this in real life applications. Like now we'll learn about one application, that is each of 93 students in this class owns a personal computer. Everyone who owns a personal computer can use a word processing program. Therefore, Jake, a student in this class, can use a word processing program. Here the C of x, we are doing 3 statements, that is C of x, P of x, and W of x. C of x is in this class. P of x is x owns a personal computer. W of x is x can use a word processing program. From the statements we are dividing this into 3 premises, that is for all x in the class owns a personal computer. Second premise is for all x owns a personal computer can use a word processing program. Third premise is Jake is in this class, and with this we need to conclude that Jake in this class can use a word processing program. So by step we should conclude this. We should conclude that Jake, a student, can use a word processing program. That is, first we will compare premise 1 and premise 3. First we will change that premise 1 in universal specification, that is Jake in this class owns a personal computer. So by comparing premise 1 and premise 3 by using modular spoons, we can say that Jake owns a personal computer. Then we will compare this modular spoon statement and premise 2. That is, first we change premise 2 by universal specification, that is Jake owns a personal computer can use the word processing program. By using modular spoons, we can conclude that Jake, who is in the class, can use a word processing program. This is one of the real life application in which we can use rules of inference. Thank you.
Now we will see the application of rules of inference and quantifiers. Here P implies Q, therefore Q it is a modus ponens and its corresponding tautology is P and P implies Q implies Q. So by looking at the example, consider let P be it is knowing and Q be the I will study discrete maths. Answer for this example is, if it is knowing, then I will study discrete maths. This means P implies Q, and if it is knowing, it is a P, so therefore I will study discrete maths. This is an example for modus ponens. Next, look at one more example. If I eat spicy food, then I have a strange dreams. I have a strange dreams if there is thunder while I sleep. Next, I did not have a strange dreams. So let us take S equals to I ate spicy food. D equals I had strange dreams. Then T equals it thundered while I slept. So here, if I eat spicy food, then I have strange dreams. This means S implies D. I have a strange dreams if there is thunder while I sleep. This is T implies D. Next, I did not have strange dreams. This means negation D. Here the steps and reasons. S implies D means premises 1. Yeah, and T implies D means premises 2. Negation D means premises 3. Next, step 4, we took negation T. So by modus tollens from equation 2 and 3, we get I did not thunder while I slept. Then negation is from modus tollens from equation 1 and 2, I did not eat spicy food. Step number 6, negation T and negation is this is solved by using conjunction from 4th and 5th step. That means it did not thunder and I did not eat spicy. So this is a application for the rule of inference and quantifiers.
Good morning everyone. Today I will be discussing about the applications of the rules of inference using this example. So we take this example and understand the rule of inference applications. Everyone in the New Jersey lives within 50 miles of the ocean. Someone in New Jersey has never seen the ocean. Therefore, someone who lives within 50 miles of the ocean has never seen the ocean. Now we break down this into three statements. That is, g of x is x in New Jersey. O of x is x lives within 50 miles of the ocean. S of x is x has seen the ocean. So we take one premise and conclusion. So we try to reach from premise to conclusion using some steps, using rule of inferences. So what we take premise is, for all x, j of x implies O of x. That means for all the people in New Jersey, if the people live in New Jersey, then they live within 50 miles of the ocean. This is the premise one. So what is the conclusion? For some x, j of x and not s of x. That means people living in New Jersey and not seen the ocean. This is the conclusion that we have to get. Now we will come from premise to conclusion using these steps. So we use the rule of inference existential instantiation. For some x, p of x implies p of c. C is an element of domain in existential instantiation. So p of c for some x, j of x and not s of x. The third step is j of y and not s of y. Here y is the element of domain. Existential instantiation on 2. Apply simplification on step 3. We apply simplification on step 3, that is j of y. Use the rule of inference universal instantiation. Universal instantiation is for all x, p of x implies p of c. So we come to the fifth step where j of y implies O of y using universal instantiation on 1, that is this expression. Now we apply modus bonus using steps 4 and 5. What is modus bonus is P implies Q and P, that therefore it is Q. This is modus bonus and we'll be using that on O of y from 4 and 5. Apply simplification on step 3. That is, we take, using step 3, we take this expression, that is not s of y. Simplification on step 3. Apply the conjunction using step 6 and 7 and then apply extensional generalization to the final step to get the conclusion. We take steps 6 and 7, that is this O of y and not of s of y, and we apply conjunction and existential generalization to the final step to get the conclusion. So we apply and operation between step 6 and step 5. So we get this expression that is in the 8th step, that is O of y and not of s of y, conjunction from 6 and 7. Therefore, the conclusion is someone who lives within 50 miles of the ocean have not seen the ocean. So with this we conclude this example.
Today I am going to discuss about the conclusion of the application of rules of inference and the quantifiers. Overall, the rules of inference and the quantifiers is essential for the ensuring the validity and the soundness of the logical reasoning in the various fields. By utilizing this principle, we can derive various conclusions to mathematical theorems, verify software applications correctness, and express the generality in the logical expressions. Thank you.